Yeah, so last class, course introduction, Java overview completed. Yes, course introduction explained. Last two sessions, course introduction, and then Java overview of Java explained. Yes, today starting, yes, actual topic. Today starting actual topic. Last two classes, just only introductions completed. Okay, yes. Today starting from the basics. 1 second. Format. And yes, today starting from basics. Yes, before going to Java, there are some software basics. So once you cleared about all that software basics, then easy to understand here. Yes, starting from the basics. Right? 1 second. Yes, you guys not necessary to write in the running notes. Yeah, here it's there in document here. So in document, I have prepared everything. This one I'll share with you. Okay, this one I'll share with you. Yes, sir. Yeah, so this font is definitely getting a reason my laptop changed. Not this one. Today laptop changed. Okay. Here, this is the document for you. Yes, I'll share with you. Yes, no worry about running notes. Not necessary to write any running notes. Just to try to understand classes here. Just to try to understand classes. Okay. Yeah, just a minute, guys. I'm taking some water. Just 2 minutes. Yeah. So before going to Java, there are some software basics. Okay, like system software, application software, about compilers, about interpreters, low level language, high level language. There are some basics. Okay. Yes, even non-IT background guys also can understand easily here. I'm starting basics, so non-IT background students also can understand here. So initially, all these basics like yes, like what is software? Yes, what is system software? What is application software? Next about voice, and then yes, about voice. Next, so what is front end? What is back end? This kind of things here. Next, yes, here language and packages. Yes, low level language, high level language. So these are some basics here. Okay. Yes, next. Yes, low level language, high level language. Next about yes, interpreter and compiler. Yes, about interpreters and compilers. So once completed, starting Java. So before Java, there are some basics. Okay. Yes, I'm starting with basics. Yes, last two classes just introductions and about course introduction only discuss, nothing discuss. Today starting subject. Today starting subjects. Yes, starting from the basics. Here starting from the basics. Okay. Yes. See, computerware. See, computerware. So, computerware basically two categories. One second. Okay. Yeah. So, computerware basically two categories. So, first one, hardware, and second one, software. Hardware and software. So, computerware basically two categories. First one, hardware, next one, software. Hardware and software. Yes. What is hardware? What is software here? Hardware, these are physical components of a computer. Hardware is a physical components of a computer. So hardware is a physical components of a computer we can touch. Like yes, screen, keyboard, mouse, next hard disk, RAM memory, and all the hardware components. So these are physical components of a computer. Hardware is a physical components like keyboards, mouse, monitor, hard disk, RAM memory, like that. But not necessary for us. We are the software engineers. So let us start with software here. We are the software engineers. So let us start with software here. Software. Okay, software. So what is software here? Software, yes, it's a yes collection of programs. In software, everything is a program. Yes, everything is a program. Yes, in software, everything is a program. It's a collection of programs. Yes, it's a collection. Yes, software is a collection of programs. It's a collection of programs. Okay, software. In software, everything is a program. It's a collection of programs. It's a collection of programs like C, C++, Java, something like that. Right? Next here, software. Yes, basically two categories. Software basically, yes, two categories. Software basically two categories. Okay, software basically two categories. First one, yes, system software. First one, yes, system software. And second one, application software. And next one, application software. Okay, yes, here software basically two categories. First one, system software. And next one, application software. Yes, what is system software? What is application software? So these are very basics. So before going to Java, these are some basics here. System software. What is system software? System software, it interacts. Yes, it interacts with hardware. Yes, hardware components. It interacts with hardware components. System software, it interacts with hardware components. Example, OS, operating system. Yes, operating system comes under operating systems. So operating systems, it's a system software. Okay. Yes, system software and application software. System software, it interacts. It interacts with hardware components. Interacts with hardware components. Yes, example, OS. OS is a system software, right? Yes, application software. What is application software? See, application software, yeah, this is for the purpose of application development, for the purpose of application development, for the purpose of application development. So this is for the purpose of application development. Yes, applications, apps. See, in our daily life, we are using many applications, right? In our daily life, there are many applications we are using, right? For example, your mobile. In your mobile, there are many applications, right? Check your mobile. So which is mostly used application in your mobile? Which is mostly used application in our day-to-day life? In our day-to-day life, we are using many applications. Okay, mostly used application WhatsApp, right? Yes, it's a WhatsApp. So WhatsApp, it's application, the chatting application. So WhatsApp, okay, right? Yes, maybe Facebook using, okay, right? Yes, maybe, yes, online shopping applications. Yes, online trading. Yes, online trading. Yes, online trading apps. Okay, right? Next, banking applications, banking. Yes, banking apps. Okay. Next, Zoom, online meeting applications. Like this, there are many applications, right? Okay, there are many applications here. So in our day-to-day life, we are using many applications here. How to develop such kind of applications as application software? So here is the application software for the purpose of application development. Yes, application development. Yes, in our daily life, we are using many applications, right? To develop such kind of applications, here is application software. Yes, application software. Best example, Java. Java is a mostly used application software. Compared to anything, Java is a mostly used application software. Java. Yes, next, .NET. .NET. Yes, C and C++. Okay, next Python. So there are application softwares. Python, yes, maybe databases. Yes, like there are yes many application softwares. Okay, there are many application softwares we are using here. Hundreds of softwares in the market, hundreds of technologies. Okay, something like languages. Okay, some language we are using here. So languages. Okay, yes, some tools we are using here. Languages, tools. Next packages. There are many things we are using. Yes, in software here, there are many languages like Java, C, C++, Python, some languages, tools like testing tools. Okay. Yes, AWS tools, DevOps tools. Like there are many tools we are using, reporting tools. Okay. Yes, next, big data tools. There are hundreds of tools we are using. Right. Next, packages like ERP package. There are many things we are using, right? Hundreds of technologies. Nowadays, tools and language package, there's hundreds of things we are using. So which is exactly application software and which is exactly system software here? See here, system software, system software, it interacts with hardware components. System software, it interacts with hardware components. Yes, OS is a system software. Only OS can interact with hardware components. Only OS. Only OS can interact with the hardware components, other cannot. So only OS comes on a system software. Okay. So only OS is system software. So except OS, except yes, except operating systems, all are application softwares. Except OS, all are yes application softwares. All are application softwares. All are application softwares, right? Except OS. Except OS, remaining are application softwares. That's it here. Okay, right? Yes. So here, yes, application software, except OS, except OS, remaining all are application softwares. See, operating systems, examples, operating systems examples, right? So what are the examples of OS here? Windows. Windows is a OS. Yes, Windows. Yes, Windows is a OS. So Windows is a OS. Linux is a OS. Linux is a OS. Right? Mac OS. Mac OS. Okay, right? Yes, next mobile applications, Android is the ways, right? Android. Next iOS, right? Next Solaris. Like there are different operating systems, except OS remaining all are application softwares. I hope you understand, guys. Okay. See here, software basically two categories. Software basically two categories. So first one system software and next one application software. Here system software, yes, it interacts. It interacts with hardware components. System software interacting with hardware components. Interacts with hardware components. Right? Example OS. OS is a system software. OS is a system software, right? Yes, application softwares for the purpose of application development, for the purpose of application development. Okay, right? Yeah, these kind of applications. Yes. So application software examples. Yes, languages, tools, and packages. There are many things here. There are hundreds of technologies nowadays we are using. So which is exactly yes, system software and exactly application software. See, only ways can interact with the hardware. So only ways can interact with the hardware. So OS is system software, except operating systems. Remaining all are application softwares. Except operating systems, yes, remaining all are yes, application software. OS like Windows OS, Linux OS, Mac OS, Android. So these are the operating systems. Except this, remaining what are things we are using? Maybe testing tools using AWS tools, DevOps tools, maybe some languages. All technologies comes under application softwares. Maybe databases, even MS Office. Like this, all are comes under application softwares. Only these are Operating systems comes on system software. Except which remaining all are application softwares. Okay, fine. See, yeah, this is today's class document here. Yes, introduction to software. Yes, software is a collection of programs. It's a collection of programs, right? Software basically two categories. Software basically two categories. System software, next application software. System software and application software. A system software, it interacts with the hardware components. Application softwares for the purpose of application development. Okay, right? System software example ways. Same thing it's there in document here. Same thing I have prepared. Same as this. So you guys, running notes is not necessary. Just you follow this document enough. Just you follow this Word document. So everyday classes, yes, you can follow this one here. Running notes is not necessary. After finishing class, read this document once, enough, right? Okay, fine. Okay, yes, right? Yeah, 1 second. Yeah. Now, what is Java? What is Java? System software, application software. Yes, what do you understand? As for my explanation, what is Java? Java comes under application software. Java is application software. Java is application software. Okay, right? Yes, our topic is about application software. Topic is about application software. So before going to application software, so before going to this topic, first let us see something about OS. So what is operating system? Let us see something about OS. Yes, what is OS? Yes. So what is operating system? 1 second. Yes, what is operating system? Let me explain about OS. 1 second. Mhm. Yeah. So topic is about OS. Yes, some question for you guys. Some question. Yes. Some question. Can we run any program without OS? Without OS. So simple question. Can we run any program without OS? That is question. Yes. Anyone can
No,
you answer?
sir. No, sir.
Yes. No. Answer is no. So can we run any program without OS? Answer is no. Say without OS we can't do anything. Okay, here simple question. Can we run any program without OS? Answer is no. Without OS we can't do anything. If no OS, no computer. If no OS, no computer. Yes. See, except BIOS. Except BIOS to run all software programs OS requires. All software programs OS requires. So here BIOS is not a software, it's a hardware. Okay, BIOS. So except BIOS program. BIOS is not a software. Except BIOS to run all software programs. To run all software programs OS requires. So what is BIOS? So what is BIOS? BIOS stands for yes, basic, yes, input and output system. Basic input output system. BIOS stands for basic input and output system. BIOS stands for basic input output system. Yes, let me show the BIOS. BIOS in your system. That BIOS image. Yeah, this is BIOS. Right, this is BIOS. BIOS in computer. So BIOS, it's a hardware. Yes, BIOS is a hardware program. Yes, it's a BIOS chip. BIOS chip in motherboards. It's a BIOS chip in motherboards. BIOS chip, right? See what happens here. Once you power on system. So once you power on system, first of all, power goes to BIOS. Now this BIOS is responsible to boot operating system. So first of all, power goes to BIOS. So this BIOS chip contains some BIOS program. That program is responsible to boot OS. Yes, booting OS. Right? BIOS is responsible to boot OS. Okay, fine. Right? Yeah. Yeah. So BIOS. So BIOS stands for basic input output system. Basic input and output system. Yes, BIOS is a yes hardware. BIOS is a hardware program. Yes, it's a chip level program. Yes, it is a yes, it is a chip level program. It's not a software here. It's a chip level program. It's a chip level program. Okay, it's a chip level program. Okay, right? Yes, it's a chip level program. Right? Yes. So BIOS is a hardware program. It's a chip level program. So what's the task of BIOS here? So here BIOS is responsible. BIOS is BIOS is BIOS is responsible to boot operating system. BIOS is responsible. Yes, responsible. Yes, to boot. So BIOS is responsible to boot. Yes, OS here. To boot operating system. Okay, BIOS is responsible to boot OS. So what is booting process here? Okay, so here BIOS. BIOS stands for basic input output system. Basic input and output system. BIOS is a hardware program. Okay, hardware program. Okay, yes. So it's a chip level program. Yes, BIOS is responsible to boot OS. What is booting here? So what is booting? Yes, booting yes is a process. Booting is a process. Booting is a process of loading OS from yes hard disk to RAM memory. From hard disk to yes RAM. Hard disk to RAM. Okay, hard disk RAM, right? See in your system there is a OS. C drive. C drive, D drive, right? Yes, it's a hard disk. So hard disk, right? It's a hard disk. Yes, C drive. Inside of C drive, Windows space. It's a Windows space, right? See that? It's a Windows space. Here this is complete Windows file system. That Windows space, right? So once you power on your system, first of all, power goes to BIOS. Yes, here they say BIOS program. Here they say BIOS program. Yeah, this BIOS program loading voice from that Windows voice from hard disk to RAM memory. Loading voice from hard disk to yes BIOS Windows voice, right? That Windows voice. Yes, Windows voice. So this Windows voice, right? That Windows voice loading from hard disk to RAM memory. See here voice running in RAM memory. Yes, here it's a Windows voice, right? This Windows voice. This is Windows OS. It's running in the RAM memory. This Windows OS running in the RAM memory. Right? So this Windows OS running in the RAM memory. So this one running in the RAM memory. Right? Yes. So here BIOS. So BIOS is responsible for the booting OS here. Booting is a process. Booting is a process of loading OS from hard disk to RAM memory. Hard disk to RAM, right? That's it. So this is about BIOS. Okay, right? Yes. So once you power on system, first of all, power goes to BIOS. That BIOS program is responsible for the booting OS. Okay, fine. Now, let us come to what is OS exactly. So topic is about OS, right? Yes, what is operating system? So topic is about OS. So what is operating system? Let me explain. So what is operating system? Yes, what is operating system? 1 second. So what is OS? So what is operating system? See your computer. In computer, there are different layers. Different layers in computer. Yes. So first of all, yes, hardware components. Here, there is some hardware components. Hardware components. On top of hardware components, yes, on top of hardware components, who is running? Operating system. Yes, operating system, right? Yes, here is a hardware components. On top of hardware components, who is running? On top of who is all programs like yes, C and C++. Okay, maybe yes, Java. Yes, maybe yes, Python. Yes, Python. Yes, maybe MS Office. Even to run the MS Office also who is required. To run MS Office also who is required. Okay, here this is your computer. Yes, what is OS? Let me explain about OS here. So this is computer. In computer, so first of all, hardware components. On top of hardware components, OS running. On top of OS, yes, all programs like C, C++, Java, Python, MS Office, for all of these things, OS required. Even Zoom application also running on top of OS. Suppose here, see this. Notepad also running on top of OS. Yes, that Word also running on top of OS. All are running on top of OS. So these are all our application softwares. All these are, yes, application. All these are application softwares. Yes, all their application softwares. All these comes under application softwares. Okay, right? All these application softwares. Okay, 1 second. Yes, all these are application softwares. Yes, so application soft. All these are application softwares. Okay. Yes. See, hardware components. On top of hardware, there is a OS. On top of OS, all the application software. See, OS comes under system software, right? It is system software. OS is system software. It's a system software. See, try to understand. So this is computer. Yes, computerware. So previously we had discussed computerware. Yes, computerware, two categories, hardware and software. Right? Computerware, hardware and software. Hardware and software. See here. Yes, computerware, hardware. This is hardware and these two layers is software. So here hardware and software. These two layers are software. Yes, computerware here, this is a hardware and these two layers software. Next, see in software, software basically two categories. First one, system software. Next one, application software. System software and application software. See, look at this. Yes, see, first one, system software. Next one, application software. That's it here. So computerware, hardware. Next here, these two layers, software. In software, first one, system software. Next one, application software. System software. OS is a system software. Great. Application software, C, C++, Java, all the application softwares. Okay, fine. I think this whole thing is computerware. So computerware, yes, hardware and software. In software, system software, application software. Okay, fine. Yes, here OS can interact with hardware. On top of hardware, OS running, right? So interacting with the hardware. So it's a system software. 1 second. See, now on top of which all the programs running, right? All programs running top of OS. So OS is giving platform. OS giving platform. On top of which all are running. So you can OS acting like a platform. So OS acting like a platform. So what is OS means? Yes, it's a platform. So OS is a platform. Yes, it's a platform. It's a platform. Yes, where we can run, yes, all the application software. All the application software. Yes, all the application software. Right? Yes. So OS is a platform. So what is operating system? Yes, it's a platform. So what is OS? It's a platform. OS is a platform where we can run all the application, yes, software, all application software. That's it. Okay, so OS, on top of OS, all are running on top. So it's giving platform. OS giving platform. On top of this OS, all are running all the application softwares. So all applications, maybe MS Office, yes, maybe Word document, maybe Notepad, even Zoom applications, all are running on top of OS only. Maybe Zoom application, yes, maybe WhatsApp running, yes, maybe Google Chrome running. So whatever it is, all are running on top of OS. It's a platform. Simply, OS is a platform. So OS is a platform where we can run all the application software. See, not only platform here, not only platform, yes, sometimes not only platform. 1 second. Yes, not only platform here, sometimes see. Okay. So but these programs generating data. Yes, output of all these programs. Output of these programs, first of all, deliver to voice and then transfer to output device, right? Yes, output of all these programs. See, output of these programs, deliver to voice and then transfer to output device, right? Okay, so output of these programs. So output of these programs, first of all, deliver to voice and then transfer to output device. Suppose input data. Yes, keyboard data. Keyboard data first of all goes to voice to these programs, right? So between these application software, hardware components, so voice acting like a middle layer, right? Like a mediator. So voice is like a mediator. Okay, it's a middle layer, like a mediator between application software layer and hardware components. So means it's an interface. So voice, it's an interface. Yes, next one more thing, it's an interface. It's an interface between yeah, this application software layer. Interface between yes, this application software layer, yes, application software and hardware components. Okay, so between these two layers, right? See, so your OS acting like interface. It's an interface between application software and hardware components, right? Yeah, that's it. So what is OS means? It's a platform. OS is a platform where we can run all the application software. Yes, not only platform, even it's acting like interface. Interface between application softwares and hardware components. Interface, right? Next. So one more point here. Inside of OS, yes, inside the OS there is a library. In every OS there is a library. That library contains all yes input output functions. Library is a collection of input output functions here. Every OS has its own library to communicate between application software and hardware components. Yes, every OS, maybe Windows OS. Okay. Yes, every OS, maybe Windows OS, Linux OS, any OS. Every OS has yes its own. Yes, every OS has its own libraries. Yes, its own libraries to communicate. Yes, libraries to communicate, to communicate between, to communicate between, to communicate between application software, yes, and hardware components. That's it. That's a little bit enough. So what is operating system means? It's a platform. On top of it, everything is running. Maybe tools, maybe languages, maybe package, whatever it is. All are running on top of OS only. It's interface. It's interface between application softwares and hardware components. That's all about OS. Same topic explain document. See the document. Just you follow document here. Look at the document. Yes, here look at the document. Yes, OS. Same topic here is there. Can we run any program without OS? No. Except BIOS. Yes, same about BIOS expand here. Same, all that points, nothing missing. Same points as it is you can see in document here. Yes. So this document, excellent document, completely, yes, my experience. Self-prepared document. See, most of the trainers, yes, they will download the documents from the different Java sites. They will provide a PDFs, right? But our document is not like that. So whatever things I'm explaining in the class, same thing as it is, you can see. Same points. Single liners not missing. As it is, you can see. Okay, a document is one of the strength in our course. Document is one of the strength here. So daily class notes is not necessary. Just you can follow it here. See what is operating system. It's a platform. It's interface, right? That libraries. Same point. See this hardware on top of hardware. OS on top of OS. That application software. Same, right? That's it. So that's about OS. Okay, that's all about OS here. Yes. Now Java is application software, right? Java is application software. Now let us move to application software. Application software. In application software, there are two things like front end and back end softwares. Front end softwares, back end softwares. What is front end, back end here? See, so this is web application. Web application architecture is like this. Web application. Web application. See here, this is front end. It's a front end and here it's a backend. Front end, backend. Front end, backend. So front end means browser environment is a front end, right? So front end is a browser environment. Okay, they are front end technologies like HTML, CSS, JavaScript. They are front end technologies. So these are running at the front end. Yes, browser environment, right? Next, backend. Yes, in backend, yes, this application and database, right? Okay. Yes, previously we have discussed who working on front end technologies is a front end developer. In backend, application developer and database developer, right? Yes. So front end developer, backend application developer, database developer. These three roles is Java full stack. So these three roles is Java full stack, right? Now in this here, front end, backend, here Java comes here. Java comes here, right? See front end, suppose registration form. Today, yes, you have filled some form, registration form, right? That registration form was simply posting to backend application. So backend application taking data and storing database. And also reverse. Fetching data from database and present to browser. So this is what is happening in the any application. So front end data simply is posted to application, application database, database to application, application to that browser, right? This is happening inside the application. Okay, right? Here Java comes here. So what is Java? Java is a backend software. 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 Java comes under backend. Okay, right? Yes, Java. See this, but Java is a backend software. Okay. Yes, same thing is in document here. Just you can follow document here. Java is a backend software to develop server-side applications. Java comes under front end, backend. Java is a backend, right? Next, in front end, backend softwares here, there are two things like language and packages. Language and packages. So package is a ready-made one, ready to use. So package is a ready-made one, ready to use. So here don't have any coding. Packages don't have any coding. Like MS Office is a package, no coding. ERPs, Tally ERP. Here don't have any coding. Here don't have any coding. In languages, it's a coding here. It's a programming. C, C++, Java comes from languages. C, C++, and Java is a languages. So what is Java? Java is a language. Java is a language. Yes, let us see about languages here. Yes, topic is about languages. Languages. Language, right? Yes, in software. See, computer understanding some language. Yes, computer. Yes, understandable language. Computer. Yes, understandable language. Right? Computer understandable language. Yes, computer understandable language. Okay. Yes, computer. Yes, understandable language. Computer understandable language. Next, we are understanding some language that is kind of user understandable. Yes, user. Yes, understandable. User. Yes, understandable. Computer understandable language and user understandable language. Yes, computer understandable language and user understandable language. Okay. Yes, we are understanding some language that is user understandable language. Computer. Yes, system understanding some language. So what is computer understandable language? Let us see. Computer understandable language. Yes, computer understandable language. Yes, it depends on generation of computers. It depends on generation. Depends on generation of computers. It depends on generation of computers. It depends on generation of computers. Yes, one more question for you guys. One more question. Yes, how many generation of computers? How many generation of computers? Anyone can answer? How many generation of computers? Anyone answer? Just you check in Google, you can see. Just check in Google. How many generation of computers? How many generation of computers? There are five generations. Five generations. Five generations. Five generations, right? Five generations. Yes, five generations. Yes, first gen computer. So what is first generation computer? Yes, vacuum tubes. First generation, yes, vacuum tubes. So first generation, yes, vacuum tubes. Okay, sorry, vacuum tubes. First generation vacuum tubes. Second generation computer. Second gen. Second gen, yes, transistor based. It's electronic subject. Transistors based. Okay, yes. So totally five generation of computers here. Five generations here. First generation vacuum tubes. So vacuum tubes based here. Vacuum tubes. That vacuum tubes here. Yes, next second generation transistors based. Transistors based. Next third generation. Third generation. Yes, third generation IC based. What is IC? IC based. IC means integrated circuits. Yes, third generation IC based. So IC means integrated circuits. Yes, IC based computers. Next, fourth generation. Yes, fourth generation computer. Yes, processor based. Presently, we are using fourth generation processor based. So this is a present generation. This is present generation. Present generation. Right. Next, fifth generation. Yes, what is fifth generation computer? It's a feature computer. Tell me, what is feature computer? Presently, we are using processor-based computers. Presently, all are processor-based. What is future generation computer? What is future generation computer?
Based on AI?
Yeah, exactly. AI. AI is a future generation. Okay. Yes, AI based. AI based. So this is feature. So this is feature. Feature generation. Presently, we are using processor-based computer. So in future, AI based. Yes. What is processor-based computer understandable language? Processor based computer. Yes, computer. Yes, understandable language. Understandable language. Language is, yes, binary code, right? Binary code. Yes, binary code. Processor based. Processor based computer understandable language, binary code. So what is binary code? Binary code is like a zeros ones format. Yes, presently we are using processor based. Yes, processor based computers. Binary code is like a zeros ones format. Zeros ones format. It's a binary code. Okay, presently we are using processor-based computers. Yes, it's understandable language, binary code. Binary code, right? Yes. What is AI-based computer understandable language? So next feature, AI-based, right? So what is AI-based computer understandable language? Anyone? AI-based computer understandable language is? Anyone? What is AI-based computer understandable language? English. It can
Giving
understand
prompts.
English, English. Simply English. AI based computer can understand our English. Okay, AI based tools can understand our English. Okay, suppose for example, yes, what is AI? First of all, what is AI? Okay, so what is artificial intelligence? What is AI? So what is artificial intelligence? AI is a technology. Yes, anyone have the idea? What is AI? What is AI?
Solve the real world problems.
AI real
Yes, sir.
world problems, huh?
Yes, sir.
No, not only even processor-based computer also will solve real world programs, real world problems here. So what is AI exactly? Let me explain. AI is a technology. AI is a technology to make, yes, machines or devices. AI is a technology to make machines or devices to work like a, yes, to make machines. Yes, AI is a technology. Yes, to make machines working like a, so working like a human. So working like a human without human intervention. So without human intervention, without human intervention. Okay, without human intervention. Okay, so working like a human being, but not a human. Okay, so AI is a technology. It's a technology to make machines. Machines are devices, whatever you call it can. Okay, to make machines working like a, so working like a human. So working like a human, but without, yes, human intervention. So AI technology working like a human but no human. That's it. That is AI. So AI is a technology to make machines working like a human without human intervention. For example, suppose in your home, suppose AI-based device. Yes, best take some Alexa, right? I think might have seen Alexa. Alexa. Yes, you can. Yes, you can give instructions in English itself, right? Power off, power on. So washing machine on, off like that. Yes, if a device is there, that will take care of everything here. Okay, that will take care of everything. Yes, A device. Yes, even you can talk to A device also. Yes, A device in your home. If any A device is there, you can talk to A device. Okay, suppose yes, you are only one person in your home, so need not to feel lonely here. Loneliness not necessary. Just you can talk to A device. AI device, yes, it will listen your stories. What are your stories saying? It will listen, it will respond. Just like a human being working that is. Okay, you can talk to AI based device that will respond. It will take your data, means like your voice data and text data. Yes, that AI based device will take your voice data and text data also. See, so today, so this is text data, right? You can yes, you are able to read it, this data, right? You can understand text data. You understanding text data at the same time, yes, understanding my voice, right? AI machine also same. It can take text data and it can take voice data both. That AI devices can understand text, it can read the text data and also can take voice data. So that input data can be voice data or text data like you. So you listening voice at the same time, yes, able to read the text, right? AI also will do same thing here. AI based devices like a human being, like a human being. Oh, great. Suppose yes, you're saying about some stories. Maybe yes, what was happening in your college? Okay, just you say to AI device that will remember. In future, any question asking, it is looking for that answer, searching answer and giving right. So whatever you say, AI will listen. Okay, all things listen, it will remember. Yes, in future, yes, anything asking from the history, yes, it will take from the filtering all data from the history and giving simply answer. That's it. Okay, so like a human being, A is working like a human being. Okay, next one more example. So A is like a family member, the device is like a family member. Next, here's one more example, driverless car. Yes, driverless car. Yes, driverless car. Okay, yes, Tesla car, right? In US, Tesla cars. Tesla. Tesla cars. These are AI-based cars. Okay, Tesla cars. Without any driver. These cars go to some pickup location and picking some persons, maybe some material. So whatever you want, instructions, it will follow simply. The Tesla car. It's AI-based car without driver. Right? Yes, not only here, yes, even medical devices. Yes, medical devices. Medical AI-based devices. For example, here, smartwatches, right? Smartwatches. Yes, monitoring health. Monitoring our health. AI-based watches, right? For example, smartwatches. Yes, I'm using smartwatch. AI-based watch. That watch is completely monitoring my health, like my ECG. Okay, next, my heartbeat, pulse rate. Next, how many steps? Yes, how many foots? Yes, walking every day, and all that information it gives. Okay, every day. Yes, I'll get the all the information. Yes, it will. Yes, simply it will monitor my health. So that AI-based emission, yes, the device is working like a doctor, okay, like a family member, like a doctor, yes, like a driver, okay, like anything. Yes, not only here, even yes, civil constructions also we can use AI-based emission. Civil constructions, mechanical manufacturing, software, yes, using AI-based tools. We can generate some coding, right? Okay, like a software engineer, like a doctor, like a driver, like your family member. Okay, yes, all in place of human being, AI comes. All activities. The thing is here, AI is not complete replacement of human being. Human being, yes, have to use that AI. Yes, AI devices using by the human being. So that, yes, work becomes simple, easy. Okay. AI is not a replacement for the human being. Just human being, all the human being just using AI tools. Yes, AI based machines. Suppose let us take software. Yes, in software. Yes, AI based tools will generate all the coding. Okay, fine. Then coding generating. Okay, who will integrate all this coding here? Yes, you have to integrate, right? That AI based AI tools giving code. That code you have to customize as per the requirement. Who will customize? Yes, we have to customize. We need compulsory. Without human, yes, complete task cannot here. So the thing is here, it will reduce our efforts here. That AI-based devices will reduce our efforts. Within short time, we can finish. That is AI advantage. Okay. Yes, but it's not a complete replacement. It's not a complete replacement, just reducing human efforts. That's it here. So this is about AI. Okay, fine. Now, our topic, processor-based computer. Now, presently, we are using processor-based computers, right? Binary code. This is called as low-level language. That binary code is a low-level language. So, binary code is a, yes, low-level language. Yes, low-level, yes, low-level language. Low-level language, right? Low-level language. Next, what we are understanding, high-level language. So, low-level language and high-level language. Yes, so software, yes, languages. Basically, two categories. First one, low level languages. Okay, next one, high level language. So, what is low level language? Low level language, yes, it's a system understandable language. System, yes, understandable. System understandable language. It's a system understandable language, right? Yes, yes, it is. Yes, here system means processor. System means processor. Processor. It's a processor understandable language. Right? What is processor understandable language? Binary codes. Processor. Processor. Yes, understandable language. Yes, processor understandable language. Binary codes. Yes, understandable language is, yes. Yes, is a binary code. Yes, is a binary code. It's a binary code. Okay. So binary code zeros ones format. Binary code. That binary code is called as machine language. It's a machine language. It's a machine language. It's a machine language. Low level language. It's a machine language. Low level language, machine language. Machine means processor. It's a processor understandable language. Yes, it is in the form binary code. So binary code means like zeros ones format. Binary code is like zeros ones format. See how that binary code generating in Java I will explain. How that binary code generating in Java will discuss. I'll explain later. In Java I'll explain here. How that binary code generating next we'll discuss. In couple of days getting the topic. Yes. So here software languages, low level languages and high level languages. Low level languages. Low level language is system understandable language. System means here is a processor. Yes, it is in the form of binary code. Zeros ones format. It is called as machine language. It's a machine language, right? Next, high level languages. High level. So what is high level language? So what is high level language? Let us say about high level languages. High level. Yes, it's a user understandable language. High level. Yes, it's a, yes, user understandable. Yes, it's a user understandable. User, yes, understandable language. It's a user understandable language. Yes, it is like English language. Yes, it is like a, yes, it is like English language. It's like English language. It's like English language. Okay, it's like English language. Okay, high level language, it's user understandable language. Yes, it is like a English language. It is like a English language. Okay, example, yes. C language, C and C++, high level language. Java is a high level language. Python, Python is also high level language. Next, HTML. So these language looks like a, yes, these things. Yeah, these are, yes, looks like English language. C program looks like English language. C++, Java, all programs looks like English language. Okay, right? Then easy to understand. So these are high level languages. Java is a high level language. Java is a high level programming language. C, C++, Python, whatever the things we are using, all programming languages are high level languages. High level language, right? High level language. Okay, fine. Yes. But system cannot understand this language. C program. System don't know about C program. Processor don't know about these programs here. Java program, no. Python. So system, computer don't know about these programs. So these programs have to convert into binary code. What is system understandable language? Binary code. So all these high level languages, yes, all these high level languages have to convert into binary code. High level language to binary code. Otherwise, system can't understand it. System don't know about Python or Java, C, C++. So these programs have to convert into binary code. Yes, high level language to binary code. So which one will convert from high level language to binary code? High level language to binary code. Yes, anyone idea? High
High level.
level language to binary code. High level language, these programs into binary code. Which one will convert? Hello. Yes. So there are some devices. There are some things to convert from high level language to binary code. What are those things? High level language to binary code. The translators. What are the translators here? Someone
Compiler.
say, yeah, compiler, exact compilers. Yes, compilers. Yes, compilers and interpreters. Compilers and interpreters. Compilers and interpreters. So compilers and interpreters converting from high level language to binary code. Yes, either compiler or interpreters converting from high level language to binary code. Okay. Yes. See, today topic. Let me show that topic here. Yes. Let me review. Yes. Same thing here. It's there. Yes. Session not completed. Don't leave. Yes. Just I'm giving review. Yes. Introduction to software. Software is a collection of programs. Yes. Basically two categories: system software, application software. Java comes under application software. Yes, next about ways. Okay, fine. Right, next. Yes, in application software, front end, back end. So Java comes under back end. Back end. Right, Java is a back end. Right. Yes, next in front end, back end, there are two things like language and packages. Java is a back end language. Java is a back end language. Right. Yes, languages, low level, high level language. See, computer understandable. It depends on generation of computers. Generations. There are five generations. Right, five generations here. Yes, five generation. First generation. Yes, next second generation, third generation, fourth and fifth generation. Right. Yes, processor based computer understandable language, binary code. A based computer understandable language, English, high level language, English. Okay. So software language, two categories: low level language and high level languages. Low level language, it's a system understandable language. It is in the form of binary code. Yes, system is processor, right? Yes. So processor understandable language. Yes, high level language. It's user understandable, like English language, very easy to understand. Examples, these things, right? Yes, which is first developed high level language? C language. C is a first developed high level language. C is a first developed, right? Yes, every high level language program has to convert into binary code. Every high level language. Yes, high level language to binary code. For this, either interpreter or compiler. So interpreter, yes, or compiler. Interpreters or compilers converting from high level language to binary code. Yes, what is compiler and what is interpreter? See, compiler, interpreter both are to convert from high level language to binary code, but some difference is there. There are many differences. Okay, right? The topic tomorrow we'll discuss. Yes, almost 1 hour topic tomorrow. Interpreter compilers. After finishing, then introducing Java, about Java. Yeah, tomorrow, yes, introducing Java. So these are some basics, software basics. Tomorrow going to introduce Java. Yeah, that's all. That's all for today. Yes, any doubts? Yes, tomorrow. Tomorrow also same demo link. Yes, based on request of students. Tomorrow also demo link. Right? From Friday it will be paid link. Yes, if possible. Yes, if possible, try to pay. Yes, fee. So first of all, start with Core Java. Core Java only 3,000 rupees. Start with Core Java, then you can continue. So once everything is okay, yes, able to write the codes, and if you're able to work clearly, then you can continue with yes, Java full stack. Okay, first of all, just you start with Core Java. Only 3,000, nothing. It's very simple. Start with Core Java. Yes, at the middle of the Core Java, you can decide at the middle of the core Java. So based on your skills, see from my side, excellent delivery, no doubt. Yes, coding skills, improving coding skills. Okay, no doubt, extraordinary in my classes. Here, by the time of finishing core Java, I'll make you feel that I'll make you feel like I never yes saw this kind of trainer. I'll make you feel like that. 100% I'm sure. By the time of finishing core Java, I'll make you feel like yes, I never saw this kind of trainer in my whole career from LKC to today. I'll make you feel like that. 100%, no doubts. 100% guarantee from my side. Okay? Yeah. So that's all for today. Yes, if possibility is there, pay the fees. Okay? Yes. Tomorrow also, same link. Tomorrow also same link, no change in the link. From Friday, link will be changed definitely, 100%, right? Yeah, that's all. Yes, any doubts? Any doubts? If no doubts, let us wind up session for today. Shall we wind up session?
Duration of this course?
Yeah, someone asking is something. Ravi.
Yeah, actually, what is the duration of this course?
Yes, Java full stack. Java full stack is 5 months. Core Java only 2 months.
2 months, okay.
Yes, Core Java only 2 months. Within 2 months, I'll finish. Computer time is computer time, no doubts. Okay. Within committed time, yes, never dragging course. Committed time is committed time. Within commitment, 60 to 65 days, I'll finish. Yeah,
Okay.
that's all for today. Yes, still any doubts? No doubts, right? Yeah.
Yeah, which topics is covered in core Java? I mean, mm,
Topics are, course our
yes,
topics are.
yes.
1 second, do one thing. Yes, go to Durgasoft, Durgasoft new batches.
Okay.
Yes, new batches. Open that new batches. Yes, actually, on day one session, explained what is syllabus and all that. On day one, explained already. See here, core Java. Yes, core Java, you can see. Course content. Open
Mhm.
course content, you can see. So they are the contents.
Okay.
Yes, here you can see. Points wise, very clearly. Topic
Mm-hmm.
wise. Yes, here's first initially basics. All the Java basics. Okay. Yes, today, introduction to software, introduction to voice, generation of languages. First three topics completed today.
Okay.
So next Java. So tomorrow starting Java. Yes, next interpreters, compilers, and all that here. Okay. Yes.
Mm-hmm.
So next
Fine.
groups concepts. First initially Java basics like
Okay.
operators, control statements.
Mm-hmm.
Okay. Next searching techniques, sorting techniques like this here. Next oops. Yes, oops topics. And next strings topics. Next exceptional handling topics. Next collection of framework topics. So next is iOS teams, that file handling topic. Next networking, multi-threading, right? Yes, apart from Java 8 features, including Java 8 features, this course.
Yeah, fine.
You can
And
see
what?
here. Just
Yeah.
go to Durga website. Yes, just you search for Durga new batches. New
Mm-hmm.
batches, you can see here. Yes, core Java syllabus.
Mm-hmm.
Yes, course content. Click here and
Yeah.
open, and you can see, right? Yeah.
Yeah. And what about software installation and
Yeah, I will explain how to install software and all that. Java
yeah.
installation and
Uh,
all everything I'll explain very clearly, right?
yeah, sure.
No
Thank
worry. I'll explain. Okay. Yeah.
Yeah.
So,
Yeah. Tell me.
so,
Tell
so
me.
Java have any special qualifications over Python? So this is my interview question. Why you choose only
Java
Java, not
different. Python just is a scripting language using for data processing. But Java is different. Java
They asking
has
they asking me
frameworks.
Python.
Java has
So
its own
yeah, they
framework
are
to build it different. Yes, Java specialties to build any kind of applications. Java small applications, large scale applications like standalone applications, web applications, enterprise applications. With Java, you can build any kind of application. Okay, Java has any kind of applications you can build, small scale to large scale, but Python not possible. So Python is a scripting language. Python is a scripting language using for data processing. Python is only for data processing, not for building big applications. Okay, enterprise applications. With Java, we can build enterprise applications. That's the reason Java is leader in the market. Clear? Enterprise application means online shopping application, online trading applications, banking applications. That kind of applications we can build using Java. Python, no. With Python, we can't build the banking applications, online trading applications. With Java only possible. Clear?
okay, sir.
Yeah. Next. So here our answer. With Java, we can build small applications to big applications, means enterprise applications. Small applications to enterprise applications. That is, yes, Java capability. Right? Yeah. Next. Any other doubts? Yes, going forward, I'll explain many topics about Java. Don't worry. Right? Yeah. Thank you, guys. See you tomorrow.
Yeah, thank you,
Yes.
sir.
Have a great night. See you tomorrow.
Thank you.